We're going over the quadratic assessment review. I'm going to go over questions 1, 2, 7, and 10, which is a good range of what you're going to need to know for the test. All of the questions on the review are helpful, but since they're repetitive, I'm only going to go over each concept once. So in question 1, you can see that the equation for the rocket that Zip and Zoom just built is here. Negative 16t squared plus 120t plus 4. And the first question is, what is the starting height of the rocket? So if you plugged in 0 for time, since you haven't actually launched the rocket yet, you would end up with 0 for your height. So we can pretty much assume that C is always going to be our starting height. So our starting height here is 4 feet. And I'm going to label that on the graph. Since my time is 0 and it is a y-intercept, it's going to be 0, 4. I'm going to go ahead and label also my axes, since I'm going to have to do that. So the x-axis is time, and the y-axis is height. Okay, B is asking, Zip is wondering what the height of the rocket will be after 2 seconds. So since they are giving us the time, 2 seconds, and we're looking for the height, we can just plug in 2 for t, which is also x. Okay, so we're going to go ahead and plug that in. H equals negative 16. Instead of t, I'm going to put in 2. And then we can just solve it. So negative 16 times 4. And we end up with 180 feet for the height after 2 seconds. I'm going to go ahead and put that also on the graph. 2 for my time and 180 for my height. So question number 2 is also following from question 1. It's still about the rocket. It has the same equation. Except for now it says that Zoom thinks that the maximum height is going to be at least 300 feet. And we have to determine whether or not he is correct. So in order to do that, we have to find the max height. And to find the max height, we first need to know the time at which the max height occurred. So that is going to be our axis of symmetry. Here's our axis of symmetry. Remember that our axes were time and height. So if we find the time at which it occurred, then we can plug that in to find the height here. Okay, so we're going to go ahead and plug that in. X equals negative 120 divided by 2 times negative 16, which is negative 120 divided by negative 32. So x equals 3.75 seconds. So this is the x of my vertex. I don't yet know what the maximum height is, so I'm going to plug that back in now for t to be able to find my maximum height. So negative 16 times 3.75 squared plus 120 times 3.75 plus 4. Okay, so when we square 3.75 and then multiply it by negative 16, we get negative 225 plus 120 times 3.75, which is 450, plus 4. And that is going to give us 229 feet. So my maximum height is 229 feet, so it does not reach the 300 feet, so he is not correct. And I can also go ahead and graph that here. Okay, so this is another question. This one is going to show us how to do intercepts. It says a model for the height h of a springboard diver t seconds after leaving the board is this equation right here. In how many seconds will the diver hit the water? So since you're looking for that point here, where he'll hit the water, this is your intercept. Okay, so going back to the other question that we did before, what would be our starting height? Remember, starting height is always your C. So I can go ahead and label that point A, since I'm going to have to do it next anyway. Oops, I did that wrong. So it would be, oh no, I did it right, 0, 32. Okay, so there is your point A, which I'm already doing the second question in advance. Okay, so now to find my intercepts, I'm going to use quadratic formula. And I can take out a GCF, since they have a GCF of 8, all 3 numbers. So if I take out a GCF, I'm going to end up with negative 2t squared plus 3t plus 4. And the reason I want to do this is because now my A, my B, and my C are much smaller numbers. And that is a lot easier to work with than the larger numbers. So we have negative 2, 3, and 4. We're going to go ahead and plug into quadratic formula. So if you don't remember the formula, it's negative b plus or minus the square root of b squared minus 4ac all over 2a. So negative b plus or minus the square root of b squared minus 4 times a, which is negative 2, times c, which is 4, all over 2 times a, which is negative 2. If we solve that, we get negative 3 plus or minus the square root. This is going to be 9 plus 32, which will give us 41. And if I find the square root of 41, you're going to have a calculator, so you'll be able to do that. It is 6.40, so I'm just going to write 6.4. Remember that you have to then split it up into two problems. So we have x equals negative 3 plus 6.4 over negative 4. And x equals negative 3 minus 6.4 over negative 4. Now, this one here is going to give me a negative number. So I don't even need to do that because I can't have a negative time. So I'm going to go ahead and do only this one. So I get x equals negative 9.4 over 4, negative 4, which is going to give me a positive 2.35 seconds. So it took 2.35 seconds to hit the water. So my point, since I have to put it on the graph, is going to be 2.35, comma 0. Because remember, when you do quadratic formula, you plug in 0 for h or for y. And don't forget, you also have to label your axes. This is number 10. So this problem is like the ones that we were doing on the Catapult Crunch and on the Catapult Packet, where you have to find the equation. So this one's a little bit different. We have a catapult that launches a boulder. It lands 32 feet away in 1.8 seconds. So I'm going to go ahead and draw a graph. The axes on these are a little bit different also, because your x-axis is going to be distance and your y-axis is going to be height. So if you started here and you launched it and it landed 32 feet away, then your intercepts are 0, 0, and 32, 0. Okay, we're going to be finding maximum height in a second. But the formula for maximum height here, we had done h equals 16.1 times half the time squared, but we're going to do 16 just to make the numbers a little bit easier. And it's times half of the time squared. The reason we're using this formula as opposed to finding the axis of symmetry and plugging it in is because we don't have an equation here. So we don't have a b or an a. We can't do that. We have to use the information that we're given. So we're going to plug in time for t and find the maximum height. So h equals 16 times 0.5 times 1.8 squared. So we get half of 1.8, which is 0.9, and then we square 0.9, multiply by 16, and we get 12.96 feet. So the maximum height is 12.96, but that is height, so it's my y. So for my x of my vertex, remember that it's right down the middle. So right down the middle here would be half of the distance. So if I look from 0 to 32, right in the middle of 32 is 16. So half of my distance is the x of my vertex. Half the distance, and this is the max height. That's how you find your vertex. Okay, for the next question, horizontal velocity, remember, it is the speed. So you're finding, using the speed formula that you learned in science. Distance divided by time. So you're going to plug in your distance, which is 32, divide by 1.8, and you end up with 17.78. Since it is speed, we have to use both units, feet per second. Okay, so I wrote up some things that we're going to need. I put the steps over here. so that you can see the steps that we're going to take to solve this problem. Here is my quadratic equation, which is what I'm going to be plugging into. I need all 3 points, 1, 2 intercepts, and a vertex. I don't need to plug in 0, 0 because automatically I'm going to get C equals 0. So there's my first one. Now I need to find A and I need to find B. I'm going to plug in now my second intercept into the quadratic equation. 0 is Y, 32 is X, and I don't need to plug in C because C is 0. So I get 1024 when I square 32A and 32B. So here's my first equation that I'm going to need to be able to do the elimination. Now I'm going to do the same thing with the vertex. I'm going to plug it in, 12.96 for Y, and then 16 for X. So I end up with 12.96 equals 500, oh, sorry about that, 256. 256A plus 16B. So here's my second equation that I'm going to need in order to do the elimination. Okay, so now we're going to do the elimination. So we're going to take both equations and put them on top of each other. So in order for me to eliminate B, I'm going to have to multiply all of this by -2. That's going to give me negative 25.92, negative 512, and negative 32B. So I don't need this equation anymore because I already multiplied by -2. I'm going to go ahead and eliminate the B's. And I can subtract 1024 minus 512, which is going to give me 512A. This is going to give me negative 25.92. And now to solve for A, I need to divide both sides by 512. And A will always be negative. I get negative 0.05. To find B, I'm going to plug that back into one of the equations. So I'm going to pick the first equation just because I think it's simpler. 0 equals 1024 times negative 0.05 plus 32B. Okay, so now I got 51.2. I'm going to add that to the other side. So I get 51.2 equals 32B divided by 32. And B is 1.6. So I found my A, which was negative 0.05, and B is 1.6. So I can form my equation. Remember, you are plugging into ax squared plus bx plus c. I don't need to plug in the c because the c is 0. So I'm just going to plug in A, which is negative 0.05 x squared, and B, which is 1.6x. And this is the equation that I needed to form. That is my answer.